Welcome to homework.
Okay, so we've got a cylinder made of bronze, and its radius is 6.44 centimeters, and its length, this is obviously not to scale, is 44.37 centimeters. And what we need to do is figure out what the mass of this is. Well, we're told that this is bronze, and we're told that bronze is 79.42% copper and 20.58% tin. Okay. Uh, and then we're also told that the density of copper is 8.94 grams per cubic centimeter, and that the density of tin is 7.31 grams per centimeter cubed. Okay, what assumption should we make in this calculation? Um, Basically, we're going to make the assumption that the entire volume is occupied by copper and tin, right? So there are it's important to remember, I guess, that in some respects, if you have like a cube of copper, right? Remember, at the end of the day, it's really just a bunch of atoms packed into that cube. And there will be spaces between those atoms in which there aren't any, uh, I guess, atoms. There's nothing there, right? It's just empty space. And so we have to assume that the entire volume of this cylinder is being taken up by 79% copper and 20% tin, basically. Right. So then now we can proceed. Basically, what we're going to do is we're going to calculate the volume of this. And once we have the volume, we'll be able to calculate the mass. And the way we're going to do that is that recall that density is equal to mass over volume, right? So that's like grams per cubic centimeter. That's a density, right? How heavy is a given unit volume of something. And so we can calculate the volume, no problem. And we're told the density in some respects. We're told individual densities for copper and tin, and we're told the percentage of the cylinder that is made of copper and the percentage of the cylinder that's made of tin. So if we know the density and we know the volume, we can rearrange this equation to solve for mass. And that's exactly what we're going to do. The only tricky part is that this density isn't just one number, it's a weighted average of the two densities that were given, right? So the density for bronze is going to be the density of copper times the percent copper plus the density of tin times the percent tin. And then we don't want that as a percent, so we'll divide the whole thing by 100, right? Because this would be either that or we can divide the individual percentages by 100. Same idea. Okay, so let's calculate the density of bronze from the information that we're given, right? So we're told that we've got 8.94 grams per centimeter cubed, and that we are 79.42% copper. And we're told that the density of tin is 7.31 grams per centimeter cubed, and that the bronze is 20.58% tin. And then we divide the whole thing by 100. Let's put that in our calculator. Make myself a little room here. So the density of bronze comes out to 8.94 times 79.42 plus 7.31 times 20.58, all divided by 100. I get 8.605. Let's just call it 8.60. Oh, yeah. 8.6. Yeah, 8.605 grams per centimeter cubed. And you'll notice this seems reasonable. The density of bronze is somewhere in between the density of copper and tin, and it's a little closer to being similar to copper because the bronze is more copper than it is tin. Hopefully that makes some sense, like some sense making, that the density of bronze, if it's mostly copper, should be pretty similar to copper. Okay, now we've got the density of bronze. So we can do mass equals density times volume. Well, we know the density. Oh, we still need to calculate the volume. We know we can calculate the volume, but we haven't done so yet. So remember that the volume of a cylinder is going to be the area up there times the length, right? Area of the face times the length, and the area of a circle is pi r squared, and then the length. Okay. So we have got, pi times 6.44 centimeters squared times 44.37 centimeters. And you'll notice these centimeters are going to end up squared, and then we're going to multiply it by centimeters. So the units work out. We do get centimeters cubed here. That's a good thing to check. Okay, so pi times 6.44 squared times 44.37, I get 5,781 cubic centimeters. Okay, 5,781 cubic centimeters. Let's bring that down here. So the density was 8.605 grams per cubic centimeter, and the volume was 5,781 centimeters cubed. All right, so centimeters cubed cancel. We'll just get an answer in grams. We'll just take this and multiply it by 8.605. In the end, I get 49,746 grams. We can put that in scientific notation if we want and say, I think we have 3 sig figs. So let's say 4.97 times 10 to the 4th grams.